Okay, let's get started. So we have a lot to do today, so we might as well get started now. Are there any questions? No? Okay. So last time what were we talking about? Regular expressions, right? So we have regular expression. And we had those 6 different possibilities that it could be. It could either be the empty set, the empty string, a single character, or it could be the union of 2 regular expressions, the concatenation of 2, or the star of another. So, and what did we show last time with relation to NFAs? What did we show? We showed some kind of relationship. Right, yeah. So we showed that if you have a regular expression, we can make an NFA for it. So that does not show that NFAs and regular expressions are equivalent. That's not true yet. We haven't shown that you can convert from an NFA to a regular expression. So let's actually just do an example of this one first. So, example. So let's do 0, 1, union 2, star. And I want to convert this to a NFA. Okay, so how would we actually do that? Yeah, just set it up there.
Just gonna stay this V1.
Okay. So how would we do this? So here is my pro tip with these. Start with the smallest elements of the entire regular expression, and then build and build and build until you get the whole thing. So what are the smallest, yeah, just leave it there, yeah. What are the smallest pieces of this regular expression? What are the smallest chunks of it? Is the union one of the smallest pieces of this, or are there smaller pieces? Yeah, well, what are some of them?
0, 1.
Yeah, 0, 1, and 2. So what you do here, and here's what I recommend too, is you make a little NFA for those really small cases, and then copy and paste them when you need them. So let's just make a little NFA for 0, a little NFA for 1, a little NFA for 2. And we know how to do this since we did this last time. Oops. Just making a little NFA for all 3. It's kind of like using induction in some sense. You start with the base case and then you work up inductively until you have the whole thing. Okay, so let's see. So clearly we gotta combine, we'll start working with the operators now because there are no small pieces left. So what can we do? Well, which of the 3 operations should we do? Should we do the star first? Should we do the union first? Or should we do the concatenation first? So here's my pro tip. Go as deep into the recursion as you possibly can. Yeah.
So, I think if we go as deep as possible, it'd probably be the concatenation.
Yeah. So in this case, it'd be concatenation because the union is involving something that involves concatenation. So what we can do then is let's make an NFA. Someone's calling me. Let's make an NFA for 0, 1. So I'm about to do something that you should not do. And a lot of students go down this route because it's easier, but You really need to think about this at every step. So don't do this. And I'm putting it in red, so don't do this. So for 0, 1, I'm just going to do 0, 1 like that. And that's the NFA for 0, 1. So don't do this. What's wrong with it? It does have the language 0, 1. That's not the problem. Yeah.
The first NFA accepts 0.
No, it doesn't. This is one big NFA. So if you just feed 0 and nothing else, you go to that middle state and you can't go anywhere. So it doesn't accept. It does have the right language. It is right with that respect.
When you start to expand it, it'll start getting kind of muddled up in all the other operations.
Not necessarily, because we can just treat this as a black box for the union and everything. So here's the problem. So 0, 1, what is that? That is 0, the regular expression for 0, concatenated with the regular expression 1. So you should treat this as an NFA for 0 concatenated with an NFA for 1. So, yeah, so don't do this. Here's what you should do instead. Let's just copy down our NFA for 0 and our NFA for 1, and then just paste them down here. So all I'm doing is just literally copying and pasting the two NFAs, the one for 0 and the one for 1. Yeah.
But then is there something exactly wrong with the first version?
It's the language is right, so it is an NFA for the right language. The problem is that it's not applying the method correctly. So it is an NFA for that regular expression, but the problem is that you're thinking of it as a string of characters rather than a regular expression being concatenated with another one.
But like, how would you know if 0, 1, whether 0, 1 is a string versus?
Because in a regular expression, it's the three base cases have a single character. So if it's 2 characters, then it'd be a concatenation of them. So here, we need to concatenate the two NFAs together. And how do we do that? Yeah, we connect the final state of the first to the start state of the second with an epsilon transition. And what else do we do?
We have to remove the final state first.
Yeah, we got to remove that final state. So that's what you should be doing, because it's making you think that this is a real concatenation happening. It's not a string, it's a concatenation of 2 regular expressions, because this generalizes to any concatenations of anything. Okay, any questions about that? So the technical right thing you should do is, here's an NFA for 0, 1, and then we'll copy it down once we do the union, and then copy that down once we do the star. But that's a lot of time wasted that we don't really need to do. So what I'm going to do here is I'm going to work with this NFA that we've already built and then just work building off of it. Okay, so once we handle the concatenation here for 0, 1, what is the next operator up that we need to look at once we do concat? Yeah, the union. So it says 0, 1 union 2. Well, let's make a little NFA for just 2. And we know how to do that because we've already made it. So I'm going to copy down here a little NFA for 2. And then how do I union these two together? Yeah. that operation.
The epsilon.
Yeah, epsilon.
Starting.
Yeah, we need a new start state. What color should I use? I'll do dark green. So new start state, and then epsilon our way into the other the original start states of the two machines. Okay, cool. So now we handled the union with the two, so that's all good. Anything else we need to do? Yeah, what else do we need to do? Yeah, the star. So how did we do the star operation with NFAs?
Well, we have to be careful because there's the empty string.
Yeah, the empty string. So how did we mitigate that?
We put the empty string in the beginning, and then the start state, and then the back.
And the new start state, what does it have to be?
It has to be accepted.
Yeah, it has to be a final state. Good. Exactly. So out here, I'm going to make a brand new start state that is a final state. And as was suggested, I'm going to epsilon my way into the previous start state. And then now what else did we do in addition to that? Yeah, so from the final states, other than that new one we just made, we epsilon our way to, it could be this state or the original start state. It doesn't actually matter. And I'll accept both of those ways. So we have a long transition coming back, and then a shorter one here. Okay, so that's actually it. So you always work with the smallest pieces, and then you work up bigger and bigger and bigger NFAs until you have one for the entire thing. Okay, any questions about that? You think a computer could do this? Like you just put in the regular expression and it just makes the NFA for you? Yeah. Oh, what about the NFA to DFA process, the power set construction? Could a computer do that? Yeah, surely. So the important thing that you should be realizing as we're going through these is that every single one of these things that we're doing have no thought required to be able to do them. It's just a simple algorithm to do all of this. Compute the epsilon closure, well, that's just searching the DFA, looking as far as you can via epsilon transitions. Here, it's just copying and pasting states everywhere. So just note that every single one of the things that we've been doing is a computable task to do. Okay, so let's talk about the other direction. So let's just say that we want to do the other direction. So what would we want to happen is we want to be able to have some procedure that converts an NFA and turns it into a regular expression. It may not be possible to do this. It may be that regexes are just inherently less powerful than NFAs are. It might be that case. It may be that they're equivalent, but there's no easy algorithm to do it. There will be, but it might be that that's not possible. So you'll encounter my friend quite a bit in this class. So my friend is kind of like a meme in this class about someone who's repeatedly in this class and never gets the material. So my friend says, well, let's just take this NFA, the conversion that we just did, and do it in the opposite order. So like if we have an NFA, say like this one, then we peel the outer layers off and we see, well, the outside it looks like star to me, so the regular expression is just something star. And then we move in and we say, well, it's just a state that's union between two. Well, that's just a union. So it's a star of a union of something, and then just peel the layers away until we get down to the bottom. So what's wrong with that idea? Do NFAs have to look like this? No, they do not. So that's one of the issues, in that NFAs don't have to look like this. If they did, then yeah, it'd be pretty simple to just do it in the opposite order. But that's not the case. That's kind of a shame. But it actually kind of leads to the direction that we need to go. So let's think of really simple examples of NFAs that may or may not adhere to the structure of the NFAs we've already made. So let's just do a really simple example. So it's just a simple NFA on two states with an A in between them. So what would the regular expression for this guy be? Yeah, just A. Yeah. So the regex in this example is A. No problem. Cool. Let's make it a little bigger. So let's just have an A, B, and that's it. Yeah, that's all I'm doing. I'm making 3 states instead of 2. So what would the regular expression be for this NFA? Yeah, just AB. Yep, no problem. Let's make it a little bit more complicated. So it's the same as the previous one, but I have a self loop on input C in the middle state. And the note that the NFAs we've already made don't have self loops. For when we did the conversion, they don't have self loops. But so we're already venturing outside here. So what should the regex for this guy be?
A, C, star, B.
Right. A, C, star, B. And why is that? Well, in order to accept, we need to take the A transition, and then some number of C's, 0 or more of them, and then the final B transition. So in a different color, I'm going to modify this last example by introducing this transition with D on it. So note something interesting. Actually, we'll get to that. So what would the regex for this one be?
A, C, star, B, union B.
Yes, good. Because think of it as we can take the top route, which is what we've already done, or we can take the bottom route and just skip that middle state in between. Yeah.
Does order matter?
Order of...
Like maybe it should be union.
Yeah, oh, yeah. So for union, the order can be swapped. But for concatenation, they can't be. Because like AB is not the same thing as BA. But A union B is the same as B union A. Yeah, so for union, it doesn't matter. For concatenation, it does. Okay, so what could we do? Let's just do the following. So let's just say that if only we had a way of putting a regex on the transition itself. So what could go on a transition of an NFA in the standard model right now? What could go on a transition? It's 2 things.
The alphabet.
The alphabet or the empty string. Yeah, epsilon. So 2 things can go on a transition right now. The one of the characters in the alphabet or the empty string. So if only we had the ability of putting a whole regular expression on a state. On a transition, sorry. So suppose that we were so lucky, we will be, in having a two-state NFA like this, where we have a regular expression on the transition. We can't right now, I know. But suppose it was on the transition. What would the corresponding regex be?
Just a single character.
Well, I'm saying that R is a whole regex itself. So what would be the regex for this NFA? It may seem silly why I'm asking that. Yeah.
Just R.
Yeah, it's just R. Could it be that the start state, could it be that we have some other transitions in this thing, like some transitions that go back, some transitions that loop on each of these states? Could that be possible to have? Yeah. So, and here's something interesting that will actually help us. Let's prove a very little theorem, which is very quick. Every NFA has another NFA with exactly one final state. So what do I mean by this? If we have an NFA, there must be another NFA with exactly one final state. So why is that true? So let's see. Suppose we have an NFA right here. And let's just say that there are 3 final states, just for sake of argument. Is there a way that I could modify this NFA so that it has exactly one final state?
Could you epsilon transition from one states to one?
Yeah, exactly. So we just make a brand new final state out here, and then from the previous final states, we epsilon our way over. I'm actually going to modify the theorem now. So it says every NFA has another NFA with exactly one final state and no transitions going into the start state. So why can I claim that? Because in this NFA, it may be possible that there are transitions going into that start state. So how could we modify this NFA so that its start state has nothing incoming into it?
Just make a new start state with epsilon.
Exactly. So we make a brand new start state and epsilon our way in. That guarantees that there's nothing coming into the start state. It may seem like a trivial idea, but it turns out to be monumentally important. So why in the world are we going down this route of making sure that we have a start state with nothing coming in and exactly one final state with nothing coming out? Coming out of it. The reason is, suppose that we can simplify the NFA in the middle, the states in the middle in such a way so that at the end we have exactly one transition coming from that new start state to that one final state. with a regular expression on the transition. So supposing that we have this situation. Well, if I didn't insist on no transitions going into the start state, there's no way I can get to this situation up here with the regular expression R on the transition. If there were more than one final state, then we can't get to that situation either. So the purpose of doing this is so that we can make the NFA in the middle simpler and simpler and simpler until we have exactly one transition from the start state to the only final state. So we're going to investigate that. So we're going to call a generalized NFA or GNFA is an NFA where no transitions into start state, one final state, no transitions out of it, I guess, and each transition is a regex. So why are we talking about GNFAs? The reason is that we'll make the NFA, the states in the middle, simpler by taking a state out repeatedly and then modifying the transitions in the middle like what we were doing before. So look at the example here. So the AC star B union D example. Could I just replace that whole thing with the start state going to the final state directly with the regular expression AC star B union D on the transition? Would that be equivalent? Yeah, because there's exactly one start state, one final state. So in fact, that's what we're going to be doing over and over and over. So let's actually do an example because it's on your quiz. Yeah, it's much easier to explain it with an example than actually going into the formality of it. So that's what we're going to do here. Okay, I think that's pretty good. It's not the same as your quiz, but it's close. Okay, so is this a GNFA yet? No, so what are some of the problems that it has? Why would it not be a GNFA? Yeah.
There are errors when transitions back to the start state.
Yeah, there's some transitions going into the start state. So how can I fix that? And I'm going to move it over here. So how can I fix that? So what was our idea of fixing transitions going in? Yeah.
You create a alternative start state.
Yeah.
To slot into the beginning start state.
Yeah. So we make I'm going to call it QS for start, and then epsilon my way into the original start state. Okay, well, is it a GNFA yet? No, so what are some of the problems? Yeah, there are multiple final states. And even more than that, there are transitions going out of some of the final states. In fact, both of them. So what's a simple way we could fix both of those problems at the same time?
Make a new final state,
Yeah, make a new final state.
and then epsilon to them. Or
Yeah.
epsilon both of them to it.
Yeah. So I'm going to call it QF for final. Make the two originally final states no longer final, and then epsilon our way from those two. Now is it a GNFA? Yeah, because we got the two first criteria done, and everything's a regex in every transition, epsilon or a character, and those are valid regexes. Okay, so now we're ready to do the ripping process. You guys want to rip some states? I love ripping states. It's a lot of fun to do. So, so the states that we have to rip out are every state but the new start state we made and the new final state we made. So the three states in the middle are the ones we have to rip out. And what we'll do is we're going to rip one state at a time in this machine. One thing that you should note is that there's no particular order that you have to rip the states out. As long as you rip one out at a time and keep everything fine, then it doesn't matter which order you do it. You may get a different looking regex, but it'll be the equivalent. So my advice here is to pick states at the beginning at least that have a few transitions going in and a few transitions going out, as few as possible. You don't want to handle states that have a lot of transitions going in and a lot coming out. But it honestly doesn't matter. You'll get the correct regex if you apply the method right. So the one that I would recommend in this case is Q2 to rip first, because there's only one transition coming in and two coming out. So why do I say that? So let's actually think what would happen. Suppose that we axed Q2 out. We just axed it out. Well, we gotta modify the other transitions to account for when we would have went through Q2. So what are the possible routes through Q2 that we could ever take? So I'll answer it the first time and you guys can see how it works from now on. So what could happen is, well, the only way in is from Q1. That's the only way in to Q2. But there are two ways out of Q2 originally. So that means that we're going to be making two transitions. So from Q1 to QF, for that one route that could have been taken, or, and also the transition from Q1 to Q0 via the route where it went to Q2 and then back to Q0. So as you see this more, you'll understand like where the transitions will go. So here's what I recommend. What I recommend is to make two lists, an in list and an out list, as well as to say that we're trying to rip Q2. Okay, so we're trying to rip Q2. The in list is going to be the states that went into Q2, and the out list is the states that have a transition from Q2. So what states go into Q2 originally?
Q1.
Yeah, Q1. So the in list only has Q1 on it and nothing else. Okay. Where did Q2 go out to originally? Yeah, Q0 and QF, good. So the out list has Q0, Q, and QF on it. Okay, cool. So what I'm going to do now is I'm going to copy and paste this figure. You guys wish you had Notability where you can copy the figure directly. Ooh, ah. So what I'm going to do here is I'm going to erase Q2, but leave the transitions in temporarily. I'm going to leave them in temporarily. So let's see. Well, the transition from Q1 going into Q2, what did we read? Going from Q1 going to Q2, what did we read? Just the character A. Is there a self loop originally on Q2? No, so we don't have to do anything there. Now let's say we're going to QF now. So we've read A, no self loop on Q2, and then what did we read going to QF? The epsilon. So it's A, nothing, and then epsilon. So what is A concatenated with epsilon? A, good. So the transition we're adding now is from Q1 to QF, and the thing is A. Oh wait, there already is a transition from Q1 to QF. What do we do? Well, think. We can take the epsilon route directly, or we can take this other route. You notice why I emphasized or? So what are we going to do here on that transition? Union, good. So it's going to be epsilon union A. Okay? Yeah, this is one conversion where it just pays to practice it. It's you'll get a better intuition as you do this more and more. Okay, so we took care of the Q1 to QF pair. So whenever you make this in-out list, always pick a state from the in list and a state from the out list. You go from the in list to the state that you just are trying to rip, and then from the rip state to the out state. So we picked Q1 and QF before. Now we got to pick Q1 and Q0. So again, we're going from Q1 into Q2, no self loop on 2, and then back out to 0. So what did we read going into Q2? We read A, no self loop on Q2. And then what did we read going to Q0? B. So what is the regex in total? Well, we read A going in, no self loop, and then a B. So AB. Oh wait, there already is a transition from Q1 to Q0. So what do we do? There already is one, and we're adding a transition. What do? We always union. So if we're adding a transition to one that already exists, it's always a union. I can't move it. So I'm just going to write it like this. So B was the one that already was there, union AB. And then now we can get rid of the transitions that involved Q2. So what we're really doing is we're simulating a set of transitions with another transition that did exactly the same thing.
Can you explain why you chose Q2?
Yeah, so Q2, because there was only one transition going in and 2 coming out, so we only had to modify 2 transitions. You could have picked any state. It doesn't matter. It's just whenever you do this, you want to make the transitions as simple as possible, so you don't want to have a huge regex on the transition. But any state is fine. In fact, the resulting regex will not look the same, most likely, if you do it in a different order. But it will be equivalent if you apply everything correctly. Any other questions on that? Okay, so now we have a choice of removing either Q0 or Q1. I'll let you pick. Either one is perfectly fine. But don't pick the wrong one. Q1, perfect. So let's rip Q1. You picked the wrong one. No, I'm kidding. Okay, so remember we have to make our in and out lists. So in list and an out list. So what are the states that go into Q1? The states themselves. Yeah, just Q0 it looks like. Don't write Q1 because we're trying to remove Q1. So it wouldn't make sense to talk about a transition from Q1 to itself when we're trying to remove it. So it's always a different state going into Q1. Okay, where does Q1 go to? Q0, it goes back to Q0, and it goes to QF. So we have, again, Q0, QF on our out list. So I'm going to, again, copy this, paste it here, and temporarily I'm going to delete the state Q1 but leave the transitions in so that we can see what we're doing. Okay, so I'll let you pick. Pick a state from the in list and pick a state from the out list. It doesn't matter which one since we're doing both. Yeah, Q0 from the in list and from the out list, whichever one, it doesn't matter.
Q0.
Q0, okay. It's just that students miss some of the details of this very often, so I really want to be methodical with this method. Okay, so we're going from Q0 to Q1, and then going back to Q0. So that will be a self loop on Q0. So what did we read going into Q1? A. So the transition is going to have A on it. And then, was there a self loop on Q1? Yeah, there was a B. So how do we indicate self loops on B? B star. Good. So B star. And then, what did we read going back to Q0? B union AB. So it would be wrong if I didn't put a parenthesis for B union AB. So I'm just going to put that there. Okay, cool. So that takes care of that one. What about the other possibility? Going into Q1, maybe self loops, and then going out to QF. So we read A going into Q1. We know self loop on B is B star. What did we read going to QF? Epsilon union A. So there's no transition from 0 to F yet, so I'm going to put it in myself. So A, B star, parenthesis, epsilon union A. And then I'm going to remove the other transitions because we don't need them.
I'm a little bit confused where we got the A part. Like the B star makes sense, but where did we get the A character?
Which one, the epsilon union A or which
For
part?
like the beginning part.
Oh, okay.
A, B star, and then parentheses.
So note our in list has Q0 on it. So we're looking at the transition from Q0 going into Q1 and then self loop and then wherever it goes after that.
Okay.
So we're always going from one of the in states in, self-looping maybe, and then going to an out state.
Gotcha.
Cool. Other questions? Okay, so choice of state to remove. Well, there's exactly one. So I'm going to copy it down. Once you get down to like one state left, you don't really need to make the in and out list because there's only one state there. Okay, so I'm going to remove the state. And so what's going to be on this long transition?
Oh, God.
So what did we read going into Q0, which is the state where we are removing?
Epsilon.
Yeah, epsilon. So we have nothing so far. I mean, we have an empty string so far. Then was there a self loop on Q0? Yeah, so it was that long guy. So that would be A, B star, parenthesis B union A, B, and that whole thing star. I'll show you a shortcut in a bit, but it's nice to actually do the method completely one time at least. And then did we read anything going from Q0 to that final state? Yeah, which is that guy down there. So then after that we have A, B star, epsilon union A. And then I'll remove the other transitions because we don't need them. And I'll actually try to move this over. There we go, cool. So here's a mistake that students also make. That's the NFA, that's the regex. Right, we made the regex, right? This actually happened on a real test, so don't do this. This is the regex. No, it isn't. What is it?
It's awful.
Yeah, it's awful. What is it structurally?
That's an NFA.
Yeah, so GNFA, right? What is the regex we want?
Just that.
Just the thing on the transition. So you should say the regex is this thing. Because it is showing that you understand the difference between an actual machine and a regex. I mean, most students don't fall into that trap, but it's just some do, and you should know the difference between them. Okay, so you may be thinking, well, golly, the transitions are going to be enormous if we have, like, say, another state. We're just going to have stars upon huge regular expressions, and it's just going to be horrible. Here's a shortcut you can do, and this is totally fine. You can do this. What I like to do is, say in this last example where we had the Q0 state, I'm going to relabel the self loop as R1 and the other transition as R2. So it's just a shorthand for a longer regular expression so that instead of making huge regular expressions, you're just working with small pieces. And then you can relabel upon relabel over and over. So then the regular expression we want at the end then is R1 star concatenated with R2. Because that's what we found out at the end. So I highly recommend that you do this. Is just make sure that it's clear where the R1 means, what R2 means, etc., all the way through. Okay. Any questions on this GNFA method and ripping states? So always make the in list, always make the out list, and for every state in the in list and every state in the out list, you make one transition from the in state to the out state. So I'll see you on Friday.